Excellent. Now with our VM tuned up and the operating system installed, we can go ahead and acquire the course files. Now, everything you need here will be referenced alongside this lesson, along with the necessary download links. And so this archive file will contain all of the core course files and resources and lab materials that we'll be using throughout the lessons. It will also include a challenge directory with additional challenge material, which you can work through to reinforce and extend your learning. And so the course has sort of been designed, as you'll see, in a very modular format, which makes it easy to update and expand over time. And so because of this, it's a good idea to source these archives periodically as maybe new materials and additions to the curriculum are released, so that you'll always have the most up-to-date resources at hand. My goal here is to make this sort of a living, breathing curriculum that continues to grow alongside the field, giving you fresh material and challenges as your skills develop. There are just so many areas within incident response and threat hunting that the learning journey is never truly finished. And so by keeping this material modular and expandable, we can keep building on the foundation together as the field evolves. Now, these two files won't contain all the different telemetry and artifacts we'll be working with either. We'll also be setting up a Splunk instance shortly that has preloaded indexes of post-compromised data for some of the labs that we'll be going through as well. And so with all that said, I've loaded up the course files onto my system. And so if I just open up the terminal here, you can essentially save it wherever you want. And so I just put it in my home directory under a SOC 201 folder here. And so we have this coursefiles.zip archive downloaded and ready to go. And to unzip this file, we can use the standard archive tools that are provided by the operating system. And so on Ubuntu, for example, we could open this up here in the File Explorer if we wanted to, and then just right-click on the archive and click on Extract. Or if we wanted to do it directly from the terminal, we could just use the unzip command and provide the name of the file. And that will go ahead and inflate that archive for us. And now if I run an ls here, we're going to see that we now have this course files directory that we can jump into. And once we hop inside and just run an ls, we'll notice a few different subdirectories. Resources, for example, is pretty self-explanatory, but this is where we're going to find all of the different reference material or cheat sheets or guides, and different example files that we'll be using throughout the course. The labs folder here is going to contain the password-protected lab exercises. And so you'll be unpacking and working through these to practice the various techniques throughout the course. The challenges folder here is going to hold the password-protected challenge exercises. Again, essentially additional challenge material that will be added onto over time, which you can work through to reinforce and extend your learning. And finally, we have this install package here, which contains the installation scripts and different setup tools to make getting your environment up and running as quick and straightforward as possible. And so we'll hop into this install folder in a moment, but just to show how the lab files themselves work, let's go ahead and hop into that labs directory. And if we run an ls here, we're going to notice that we have a listing of different archives with seemingly random identifiers. This is intentional. It's part of making the course more modular for us. And so each lab or example that we work through is going to be referenced by a unique identifier. And so as you progress, you can easily follow which UID is being referenced in a particular lesson or in a section of the course. And the idea here is that all the relevant files and artifacts to work through for that lab are going to be self-contained within each archive, making it easy to manage and extract and work through without confusion or overlap. And all of these individual archives are going to be password protected. This is mainly because some security software might flag certain files, even though most of what we're going to be dealing with are post-compromise artifacts or fully defanged samples anyways. But either way, you'll notice that we have a password.txt file here at the bottom. And this is going to contain the current password that you can use to unzip all of the lab archives. And so you can do that manually if you'd like. And so if open up the file browser here, hop into the class files folder under labs here, we can go ahead and extract, and it's going to prompt us for the password, and we can just type it in. So we can do it that way if we want. Or we can run the unzip command again, at this time providing the capital P argument to provide a password. Or if we wanted to extract everything at once in one command, we can use a clever one-liner to do that. And so in this case, I'm running a for loop, as you can see, essentially to loop through all the different zip files in the directory. Then we're going to run an unzip here with the capital P, and within that, we're going to run a subshell here to cat out that password.txt file. And so we're going to provide the password of whatever is stored inside password.txt. Again, this isn't to sort of hide anything. It's just to make sure that security software can't scan these zip archives and flag them and delete them on you before you get a chance to unzip them. And so if I run this, it's going to loop through all of these different UIDs and provide the inflated or the unzipped directories. So once that's been complete, I can run another ls here, and we now have all these different directories with all the class files ready to go. Now we can also go ahead and do the exact same process in the challenges directory as well. And so you can just use the same one-liner to also extract the challenge modules. Excellent. All right, now we can go back and jump into that install directory. And if we hop under the Linux folder here, we should see an install.sh script. And so this is designed to help automate the setup of our environment, and it installs some of the necessary tools or dependencies and utilities that we'll be using throughout the course. And the idea here is, again, ensuring that your system is configured consistently and sort of saves you from having to manually install everything step by step as we go throughout the course. And so we'll just need to give it execute permissions before we can install it. And so we can run a chmod here or a change mode, and then provide +x here to add the execution bit, and then provide the name of install.sh. And if we do that, now we're going to see that it's listed in green here because it has that execution bit now. So we can now execute this file. So now all we need to do is just kick it off. And so I'm going to do that with a sudo and then provide the name of install.sh. When we do that, we're going to see this usage information here. And so the idea here is that the script is also modular. And so we can install it with various options to control what we actually want to install here. But for our purposes, we want to run it with the all argument here, as we can run all the different setup options. And so I'm just going to run the script again, this time providing --all here to kick that off. And so it's just going to do a number of various things like installing or updating our system packages, upgrading our packages, and then installing a bunch of different utilities that we're going to need for the course. And so this could take a few minutes to actually run for the first time if we need to update and upgrade and then install all these packages. And so just give it some time here and let it do its thing. You might see that certain utilities are already installed, and so they'll be skipped. That's perfectly fine. It just means that we already have the versions that we need. All right, and if we see this setup complete message, then we're good to go here. And you can see it reminds us that we might want to reboot the system for all those changes to take effect. And so it's never a bad idea just to run a sudo reboot now and reboot our system here. And so now that we have a fresh install configured just the way that we like it, this is a perfect time to take a VM snapshot. And now creating a snapshot allows you to save the current state of your virtual machine. And so if anything goes wrong later, or if you want to restart a lab cleanly, you can just quickly revert it back to this baseline without having to reinstall or reconfigure everything. And there are different ways of doing this depending on your hypervisor or the setup or software you're using. Fortunately, in VirtualBox, it's pretty easy to do. We can just select our VM here and then click on the snapshot icon and then type in the name of our snapshot. And so I just like to name it fresh install just so I know, mentally that this is where I was when I got the system up and running and installed everything I needed to. And so with that snapshot taken, you now have a safe restore point to return to at any time. All right, so now we have our Unix-based analyst machine configured and ready to go.